Hi, I'm David Spetzler. I'm the president of Caris Life Sciences. I've been with the company almost 15 years now. And so there's been a lot that we've done in that 15 years. And today we're excited to talk about opportunities that now exist with the data set that we've amassed that have been previously unavailable, that really I think is going to usher in a new opportunity to advanced precision medicine, to identify new drug targets, to bring better therapies to patients. And that's really the mission of Caris Life Sciences. So we've been doing molecular profiling since 2008. We've always taken a multiomic approach. So what that means to us is measuring DNA, measuring RNA, measuring proteins, amassing as much information as we possibly can around a patient to better understand the nature of their disease, to identify therapies that they should be taking and identify patients that should be avoiding particular drugs. So avoiding a toxic therapy is just as important as finding something that's good. And so we've been building this data set and really starting to apply machine learning a long time ago. So in fact, in our current clinical offering, we have two different ML AI-based algorithms that are able to identify specific features of patients. And so we've been at this for a really long time, and that gives us a great deal of insight because we've been using the data ourselves. And so when we start to talk about the data, it really comes down to how many molecular features are you actually measuring and generating. And so it's whole exome sequencing, it's whole transcriptome sequencing. And so whole exome, of course, is every single coding gene that we know about to date. So there are about 3 billion bases in each one of our cells. We're measuring about 60 million of them, encompassing all known genes. Those genes are, of course, transcribed into RNA, and we're measuring all of the transcribed components as well. And so these two data sets together represent the broadest, deepest molecular data set in existence. And I'll go through some of the numbers in more detail later. But it's pretty staggering, the size of the data set that we have now. And it's something that we've been tracking clinical outcomes data on for over a decade. And so when we talk about the exome data, the transcriptome data, it's important to know that this is relatively new data as well. So it's not that we've got data from 10 years ago, 15 years ago that is populating this highly relevant data set. It's really starting from 2019. So we look at kind of the contemporaneous nature of the data as being that is most valuable. The standard of care has changed so much that if it's not more recent data, then it just doesn't matter nearly as much. And so application of AI ML techniques to this data set is absolutely essential. This is one of the most complex systems that we know about across all of science. Right? Looking at a single gene, looking at a single transcript is not going to give us an understanding of best how to administer new therapeutic opportunities to patients. And so if we don't take that system-wide approach, then we're missing an opportunity. And it's really too complex for the human brain to solve on its own. So we have to rely on these mathematical modalities in order to determine how best to develop new drugs, how best to treat patients, and how best to fight this disease effectively. And so that's what we're beginning to do. And that, of course, is enabled by the cloud. I mean, the computing resources required even 5 years ago to analyze a data set of this size are really unattainable. It's really, just now becoming something that is reasonable. We're talking about, 40 plus petabytes of data. To be able to analyze that in a robust way requires massive computing resources. Which is one of the reasons why we're so excited to be working with Amazon to make this data available. Because it's not just access to the data, the compute required to do something meaningful with it is also very significant. And so the reason why we have this data set is because we have amassed the world's largest collection of NovaSeqs. We have more sequencing capacity than anybody else on the planet. And we're using this every single day to generate these. So we don't have small panels that we run. If you're only running a small panel of a few hundred genes, then you're really only looking for what you already know about. So you can't do discovery if you're using a panel. Discovery requires looking for everything, looking at what you don't know about. So every single patient that comes through the lab is getting whole exome sequencing, is getting whole transcriptome sequencing, and then we're doing imaging on H&Es as well as all the IHCs that we do. So whole slide imaging is another component to the multiomic data set that becomes very, very important and valuable as we look to the future. But this investment in infrastructure is what has enabled us to amass this data set. And it's pretty exciting for us. I mean, I think nobody in the world thinks that, oh, Phoenix has the largest sequencing capacity of any city on the planet. But it's actually true. And that's pretty exciting for us. And so as you start to think about this, of course, we're measuring massive numbers of RNA and DNA in terms of the genes across hundreds and hundreds of patients every single day. But there is a funneling effect on the data, right? So not every single patient that we measure is going to be useful to answer a particular question. And so there's this natural degradation of the data as we go in and try and find out, okay, what is the subset of information that we have that can best be used to identify new therapeutic opportunities? We want to start to include, what is the microenvironment happening? What is the PD-L1 status of the leukocytes that are surrounding the tumor? And so incorporating that whole image analysis is very important to understand and present the context of the data. That context is going to be very, very important as we start to stratify patients further and further. And then, of course, the best thing is to layer in treatment data to know what was the clinical benefit that these patients received of certain therapies. What was the clinical detriment that some of them received? Can we start to identify patients with signatures that will have a toxic response? So maybe the tumor still responded, but the toxicity associated made it intolerable for that patient. And so as we start to think about this, we want to be very broad in our application of questions that can better identify patients that should be treated one way versus another. And then, of course, so many of the patients don't have good drugs available. So we've got to use this data and opportunity to find new drugs. The sad fact is that about 30% of patients benefit from 30% of the drugs 30% of the time. So that's terrible. It's the best we've ever done. It's still not good enough. And so the way that we can start to improve that is by leveraging these enormous data sets to identify new opportunities to create drugs. And that's what it's all about. So our mission is to help as many people as possible. And bringing new drugs to market is a very, very good way of doing that. And so here are some examples of some numbers in terms of when you get down and say, okay, we want to have whole exome sequencing, we want to have whole transcriptome sequencing, we want to have images, we want to have clinical data, the numbers get relatively small. So in total, our data set is sitting at about 450,000 patients. For whole exome, we've done over 200,000 patients. For whole transcriptome, we've done over 250,000 patients. But that natural subjugation of patients is real, and it happens. So by the time you get to the highest quality subsets, the numbers get relatively small. I say they're small. These are the largest numbers in the world like this. But we still need more. We have to do more. We have to expand it and be doing more and more of this type of work to be able to find these patterns. If we're looking for these rare biomarkers that are 1 in 1,000 or 1 in 2,000, then you need many, many thousands of patients to be able to find them. And that's part of the search. That's why we need to be doing this, and that's why we are doing this. And so another aspect of this is matching with very, very high quality clinical data. And so the quality of the clinical data is absolutely essential. EMR systems are not built to be research systems. They are billing systems. They are capturing procedures based upon what insurance will pay for the most part. And so going in and doing the scrubbing of the underlying data that is collected is absolutely essential to generating really, really high quality clinical data. That allows the interpretation of the genomic component to be better. And so we do this through partnership. And so we fundamentally believe that we will all be stronger together. And so our relationship with Concert AI is a good example of this, where they have some of the very best clinical outcomes data of any real world data company. And you couple that with the very best molecular data, and you get something that is better than the sum of the parts. And so we're doing as much of this as we possibly can, again, because it's going to lead to better patient care. At the end of the day, it's all about delivering better care to patients. And this is what that enables us to do. And so as you start to think about, okay, what is the opportunity that exists here with Caris data enabled by Amazon Data Exchange and enabled by the Amazon cloud? We're sitting on, I said, over 200,000 whole exome sequences. So it's actually greater than 210,000. Growing every single day. So This number is smaller today than it ever will be ever again in the future. And that's important because it's not a journey that is ending, right? This is something that continues to go on. As standard of care changes, we want to see how the molecular systems are evolving in time. Whole transcriptome, well over 250,000 whole transcriptomes. The whole slide imaging is really interesting. It's very early on in the applications, but when you couple the molecular data with those H&Es, it creates this incredible opportunity. So if you think about, the US is lucky because we have a healthcare system that will cover the cost of the sequencing, but outside of the US, it is not covered very well. So using those H&Es as an enrichment tool to identify the patients that are more likely to have the specific alterations that you care about creates an enrichment opportunity that starts to make molecular profiling available to the people around the world that need it and will benefit for it. And so there's a lot that we can do there in terms of enriching for trials, making sure the patients are getting what they need. And so this represents the largest combined clinical genomic database on the planet. There's nobody that's measuring more genes. There's nobody that has measured as many clinical exomes in oncology than us. So it is the very biggest data set available. And it's something that we can leverage to do a lot of good for the world, especially applying AI and machine learning to it, because the complexity of the data is really staggering, and we just have to be able to do that. The next part of it is validation. So we can find all of these features in the data. That may be real, that may not be real. But at the end of the day, we always want to come back to the biology. And so the other thing that we have is this enormous biorepository of specimens. So specimens where we find a hypothesis, we go in there, we want confirmation, not in cell lines, but in real clinical samples. We have those underlying samples to go back and do confirmatory testing when we find and generate these hypotheses together. And that's a really important part of this, right? It can't be just hypothesis generation. We really want to take that next step and go through the validation step. That's, again, how we're going to advance the science and the medicine as best we can. So why are we working for, or with AWS? Why am I at a conference like this? I normally go to medicines conferences or science conferences. It's because the nature of the data is different today than it was when we started. It's so big. Data security is so important. Facilitating access to the data is an enormous problem. So we had a lot of this data on tape. We're like, oh, we want to start to redo, our BAM file alignment. And we're like, holy crap, it's going to take us 9 months to move the data off of tape onto an active memory storage system that actually allows us to run these types of analyses. And so that's just not useful then. So we have to get it to a place where there's easy access, where we can start to run these novel analyses to be able to start to do more discovery work on these data sets. And that's what Amazon has enabled for us, to not worry about security. We're never going to be as good at security as they are. And we shouldn't be. That's not what our role in this is. We are the molecular science company. They are the data infrastructure company. And so that combination together really creates an opportunity for us both to participate in the advancement of science and medicine to the benefit of all oncology patients. And I think that we're going to find is that the nature of this type of data is going to inform what we do in other diseases as well. So this is the first part of precision medicine. It's certainly not the last part of precision medicine. And we're just really excited at the opportunities that exist in this space. So with that, I'm going to hand it over to my colleague here, Praveen. Thank you for your attention.
Thank you. Hello, everyone. I'm Praveen Haridas. I lead healthcare and life science vertical for AWS Data Exchange service. Thank you, Dr. Spetzler. That was an amazing discussion around Caris Life Sciences multiomics data sets. We are super passionate, super happy to have Caris Life Sciences multiomics data set on AWS Data Exchange to accelerate the cancer research for our life sciences and biotech customers. We at AWS build services based on what we hear from our customers. We have consistently heard from our customers, typically a life sciences or biotech organization, that it's really hard to find a fit for purpose data set for their specific use cases. And also, there's a lot of technical and operational challenges to exchange the data from the data partners into their environment. The story is not very different with data partners too. The data partners also said, as Caris Life Sciences Dr. Spetzler said, we are sitting on a large volume of data. How do we exchange it in a compliant way and also without going through the large operation effort? We launched AWS Data Exchange to bridge this gap so that our life science customers can get access to, can discover and access to these data set in a much faster way so that they can be more agile, access the data set at a reduced cost, and innovate faster. We launched AWS Data Exchange in November 2019. Since we launched the service, we have close to 300 plus data providers and 3,500 plus public data sets covering multiple industries, including healthcare, life sciences, FSI, ESG, among others. Data Exchange support both private exchanges and also public exchanges. What that means is a data provider or a data partner can publish their data on Data Exchange publicly or privately so that they can decide whom they want to interact using the Data Exchange service, if you will. Data Exchange also support multiple data delivery modalities, including files, APIs, and Redshift query tables. What that means is data partners can choose how they want to deliver the data based on the volume of the data sets and also their compliance requirements in terms of data sharing. And then, which means the data customers or the consumers of the data can start deriving insights on the data set on the day one of subscription, rather than setting up complex infrastructure and SFTPs and wait for 3 months before they get there. Data Exchange, or ADX as we call it, really make it easier for data partners to exchange data to their consumers, and the data customers can access it directly with native AWS services. With AWS Data Exchange, data customers or the life science enterprises who need the data can ingest the data sets from multitude of data partners directly into their S3 bucket, and they can use their own set of tools for analysis, curation, and also derive insights within minutes after subscription. Data customers can choose to access the data in a Redshift table so that the data partners are curating the data set in a specific format, and then they can start the analysis and integrate it to different production systems, if you will. For AWS, security and compliance is #1 priority. AWS Data Exchange is GDPR compliant and HIPAA eligible. It is also one of the services which has went through the high trust certification. Data Exchange is within this model, any data set that is flowing through Data Exchange, it is encrypted at rest and in transit. It is also integrated to AWS Identity and Access Management so that the administrators of the service can adjudicate how the different end users are using the Data Exchange service based on their functional roles. What that means for data partners is they can, within a few clicks of a button, they can manage the distribution of the data sets to their global customers using easy-to-use AWS Data Exchange APIs and a user-friendly console. Exactly what Dr. Spetzler said about how Caris is using Data Exchange. Data Exchange also means it gives a single pane of glass for a data consumers to find the fit-for-purpose data set they're looking for, and also exchange the data sets privately or publicly from their data partners. For instance, Caris Life Sciences have listed their data sets privately on Data Exchange, because of their compliance need. They don't want their data sets publicly visible. And they are using the AWS Data Exchange service to share the data in a private setting to their hundreds of life science customers. A life science customer can also migrate their existing subscription from hundreds of data partners using Data Exchange at no cost. Data Exchange also, if the data partners and customers decide to do billing through Data Exchange, then Data Exchange will consolidate all the data purchases into their one AWS invoice, and then which means one less vendor relationship the customer has to manage with multiple data vendors, if you will. So what that means for subscribers, so a data consumer, all that means is they have less time they need to spend on discovering new data sets, building complex ETL pipelines, maintaining SFTP infrastructure. Instead, their data scientists and researchers will be building models focusing on deriving insights on the data set within seconds after subscribing from their data partners. Due to these reasons, many life science customers have adopted AWS Data Exchange in their real-world data or third-party data strategy. For instance, Gilead has set up their internal data marketplace using AWS Data Exchange. Gilead is able to subscribe to a 36 terabyte of multiomics data set in 6 minutes, compared to 36 minutes when they were receiving the data with multiple SFTP servers and other complex integration pipeline. Moderna has been using Data Exchange in their RSV surveillance, which is enabling them in their enrollment strategies, if you will. Moderna is receiving the data sets from global set of data providers, including diagnosis lab and hospitals, in near real time in a standardized format using Amazon Redshift. So Moderna is now able to see the surveillance around where an RSV cluster is forming within their Tableau or other application dashboard in seconds because of the streamlining that Data Exchange and Redshift enable with their data partners. Moderna also said they're able to improve the efficiency of their data integration by more than 50% once they migrated to a Data Exchange plus Redshift-based data subscription from external partners. This also means it's beneficial for our data partners too, like Caris Life Sciences. Data partners is now able to find new revenue stream, new opportunities, and they are also able to reduce the operation cost by centralizing and streamlining their data distribution to Data Exchange and having their billing and taxation operation done by AWS, if you will. Customers or data partners like Caris Life Sciences have enrolled into our AWS partner network. So they're working with our account teams in a co-sell relationship, and they're able to find out new millions of AWS customers who are interested in their data set and meaningfully increasing their revenue, if you will. So how do we get started with all this? So with Data Exchange, for an epidemiologist or a translation researcher in our life science customers, we will be able to help you in finding the fit for purpose data sets that you're looking for. Data Exchange will streamline the ingestion of the data set from multiple data partners through our AWS managed Data Exchange service so that the end user can focus more on insight generation and less on setting up a complex infrastructure and maintaining it with hundreds of dollars, if you will. For a procurement manager, if you choose to do the billing, which means you can standardize your contracting all in one AWS invoice, so you have one less vendor relationship, and you also realize commercial benefits by using Data Exchange service, if you will, when billing is involved. And it also provides a central catalog so that you can see, a data procurement manager can see what are the different data purchases an enterprise has made, reducing the chances of duplicate subscription, which is apparently one of the key challenges faced by several of the large pharma enterprises, if you will. We are super excited to have Caris Life Sciences on AWS Data Exchange. We will continue to innovate with our data partners and life science customers to improve the discovery and access of multimodal data sets to accelerate the research and improving the patient care across patients worldwide. Thank you. Any questions?
There is a reception in the exhibit hall starting at 4:40, so there.
I will ask you a question. So, Caris Life Sciences has moved their data sets to UNC, and there could be more customers. How do you protect that their data does not go to unwanted hands?
They control it. We use AWS account ID. So let's say Caris is sharing the data to pharma A. Caris will ask the pharma, what is the AWS account ID? And then they share the data in different modalities like S3 bucket or whatnot, where the customer with whom they're sharing the data, their compute will come to the Caris data set, or Caris can share the data directly to them. So Caris can select whom that customer is and adjudicate if there is a bad actor and whatnot, if you will. And they are managing it using our AWS account ID because that is tied to the tax and other stuff of that customer, if you will.
And whose data is it? Is the patient's data?
Well, it's our data. I mean, it's from patient samples for sure.
And will they raise the patient? Can they raise the rights that is my data to use it or something?
It's all de-identified, so there's no individual feature that would allow identification of the patient, and most of it is consented as well. So,
that we can use it for the
cancer patients in particular are interested in helping other cancer patients.
Right. Because you missed the talk which I was delivering. We have used 2,000 plus cancer patients, lung cancer patients. We have built a pipeline or a system where we have a genomics data, there is the patient data, with a PET-CT scan of those cancer patients. And a deep learning system actually identifies, based upon the PET-CT, what mutation the patient would suffer. Based upon that, oncologists can prescribe the right kind of targeted therapy. So, do you have such kind of a data sets available in your? I'm asking about these.
Yeah, we don't have the PET-CTs, so
the genomic, which you're talking about, your molecular data.
yeah, I mean we're running whole exome sequencing and whole transcriptome sequencing on every single patient.
And where does the imaging data?
Where does the what? The imaging data? Oh.
Can you get the imaging data on board with those patients?
Yeah, we can. Not nearly as much, so we don't collect them, but we have what we've created. It's called the Precision Oncology Alliance. So it's over 80 institutions around the world that we do a much greater degree of collaboration with and data sharing with, so that we can ask new and innovative questions as well.
So my question is straightforward. Without doing biopsy, reducing the cost of NGS, like you were talking, US has the cost covered, but developing countries do not have such leeway. So can we build a tool or help patients to have a low-cost solution without having invasive biopsy or less number of genes or NGS sequencing can be done? So that is a question which we are trying to answer. So maybe your data sets, your tool on Amazon would be helpful for building such products.
Yeah, I think that it would.
So, any more questions, any suggestions for the speakers?
What stage are these patients at?
So it's primarily stage 4. As sequencing has become clinically important in early stages, it's moving in that direction. So a fair number of stage 3C as well. It's interesting. So it may be that clinically the patient is, now stage 3, but the only tissue sample was from their original diagnosis, which may have been when they were stage 2. So some of the data does go into earlier stage, but the time of sequencing is disparate from when the sample was actually collected.
Do you also have multiple time points on the same patient?
Yeah, so we've got, probably 20,000 or so where there are duplicate biopsies. And then we've just launched our blood-based assay, which is, again, whole exome and whole transcriptome. And that's where we'll see a lot of serial testing happening.
And if some scientists want to run, let's keep the imaging data on site, but we have a lot of molecular data. Let's say we take an example of lung cancer. We have NGS and patient data, you have assays or whatnot. If somebody wants to run the algorithm on your huge data set and give you insights, would you allow, or do we have to pay, or how does it work?
It depends on the nature of the collaboration. So, with academic collaborations, there are different models. Most of the time we run it and, publish together. So we do a lot of publication work.
So thank you very much. It was a great talk.
Thank you.
Both of you.
Thank you.
Thank you, everyone.